Okay, good morning, everyone. Today we're going to start section 7.4. I did not assign homework, so I'm not asking if you have any questions. Unless you have, you can put them on chat. And we're going to sketch the graph of sine and cosine. And our goal from this section and next section is to be able to find formulas for periodic functions. I mean, it's a formula that will fit periodic. But before we do that, we have to see how the graph of sine looks like, how the graph of cosine looks like. Okay, so let us go back to the unit circle because the sine and cosine were defined as the x and y coordinate of the point on the unit circle. So to be able to graph them, I really need to remind you of that, which is, I think we know them. So this was my theta equal to 0 in both region. This was my 30 degrees, which was the pi over 3, I meant 6. And this one was the 60 degrees, which is the pi over 3. So we'll go through that quickly because we've seen that. And I think I have to mute. Okay. And this was the 90 or the pi over 2. Okay. And this one was every piece is 30. So this was 4 30s. It means this was 120 or 2 60s. A 60 is pi over 3, which is 2 pi over 3. So that's really my unit circle. And then let me see how I'm going to write this. I just move it a little bit. And the theta here is 1, 2, 3, 4, 5. That's the 5 pi over 6. I'm going to write it differently. So this was the 5 pi over 6. It's 5 of them. Or in degrees, that gave me the 150. And that's the pi or the 180. So that's the full picture of the unit circle. This one is quickly. How much is this one? Can anybody tell me quick? Quickly, how much is this one? Remember, we're moving by 30 degrees. So how much was this? I'm listening. 210, absolutely, it's 210. And 210 is how much in region? 210 is 7 times 30. It means 7 pi over 3. I meant pi over 6, which makes sense. We have 1, 2, 3, 4, 5, 6. We have 7 pi over 6 going around the circle. This one was the 240. So I want to 240. It was 240 is how many 60? It's 460. It means 4 pi over 3. That's a 460. And then we have the 3 pi over 2. And then here we have the 300. And the 300 is 560. It means 5 pi over 3. And then finally, this one is the 330. 330, how many pi over 6? Quickly. 330, how many pi over 6? Because I really want you to 11 pi over 6. So that's really was my unit circle. And then the sine and cosine. Okay, so the sine here, these are the one I always told you, you memorize, the rest is simple. For 30, the sine, the cosine, that's the first coordinate was that. And the coordinate of this one was universal. Okay, and once you know this, actually you know everything. So when you hit 120, the sine are going to be, symmetry. So we're keeping the sine, the cosine is going to change, and this is going to be the square root of 3 over 2, the famous unit circle. Right here, again, total symmetry. Total symmetry, I don't memorize anything at this stage. Right here, it means I'm looking for the cosine of 5 pi over 6 and the sine. By symmetry, this point will have to be the x coordinate is the negative, the y is positive. It means cosine 5 pi over 6 is minus square root of 3 over 2, and the sine is a half. Now right here, by symmetry to that, minus a half. Cosine 210 minus square root of 3 over 2, the sine is minus a half. And then again, symmetry and symmetry and symmetry. This one is symmetric to that. So this is, what did I do wrong? You guys are not correct.
Switched it 1/2 and
right here.
February 3.
Yeah, you have to correct me. You know, I know this stuff, I know that, but I do mistake and I do stupid mistake. Why not? But I got it correct here for some reason. I have it correct here. And here, I have it correct here. So that's where I realize that I'm doing something not correct. Okay. And then finally here for the 300, this is usually I like to refer to that. So the x coordinate is positive, and this one should be minus the square root of 3 over 2. And finally, this famous one, the x coordinate is the same. The y coordinate is minus a half, okay? So this is the famous unit circle. All right, I'm gonna use it today to sketch the graph of sine and cosine. So we're gonna use this graph. So first I'm gonna retrieve the sine values, and then I will worry about the cosine. Okay, so first the sine value. So this is my angle, 0, pi over 3, I'm at pi over 6, pi over 3, pi over 2, and then the 2 pi over 3, and finally, finally, and the 5 pi over 6, and the pi. So I'm going to do those first and then the other one. So here I'm going to put the sine. I'm going to focus on the sine, and then I will do the cosine later because I want to graph them one by one. Okay, the sine. So now this is a 0. That's a half. That's the square root of 3 over 2. These are the coordinate. Pi over 2, that's a 1. 2 pi over 3, the sine is this coordinate. The sine is the y coordinate. 5 pi over 6, the sine is the y coordinate. Pi, the y coordinate. Okay, so I'm pulling all the sine value, and then let's pull all the cosine. Still the sine. The other angle means the pi, the 7 pi over 6, the 4 pi over 3, the 3 pi over 2, and then we keep adding the 5 pi over 3, and then 11 pi over 6, and the 2 pi. Okay. The sine. The sine for pi, we should memorize this, that's a 0. 7 pi over 6, that's the minus a half. That's the minus square root of 3 over 2. The 3 pi over 2 is the minus 1. That's the smallest value the sine can take. And then this is the minus square root of 3 over 2. And then this is the minus a half, and this is the 0. Okay. So, and as I said later on, we will focus on the cosine, but now I just really want to focus on the sine function. Now I want to graph it. What does it mean to graph? Okay, so I'm going to use those values. We're going to graph the sine function. So graph of y equals sine t. Okay. Right now, I'm looking at the sine as a function. What do I mean, the sine as a function? It means if I ask you back, simple, if let us say I ask to sketch the graph of y equal x squared or y equal t squared, right? Where t is the input. It means the way we do it is basically you put all the t value here, you make a table, and you ask yourself, okay, if t is 0, what's y? If t is 2, what's y? And we start collecting those points. We start putting those points and we connect them. We get the graph. Right now, we're going to think of the sign the same. Means we're going to do the following. We're going to take a graph. On the horizontal, I'm going to put the value of the angle. So the angle in radian. And here, the values of the sine of this angle. And you're going to sketch the graph verbatim by pulling off those values we have. Right. The first point of interest that I will do, and all of us are going to be doing on the graph starting on, the most important point which guide us are the following. So I'm going to put on the graph pi over 2, pi, 3 pi over 2, and 2 pi. These are the value of the angle. So I always put them here because they guide us in this problem. And then let us see how the graph would look like. If the angle is 0, the sine is 0. The angle is pi over 2, the sine takes the value 1. So now the sine value are on the vertical and on the horizontal, the angle. Now at pi over 6, it's going to take, pi over 6 is a half. So if this is a half here, that's the value at pi over 6. At pi over 3 is square root of 3 over 2. So square root of 3 is 1.7. Divided by 2, we're almost 0.8. So we should be right there. And then we simply connect those points. So that's the graph here. Okay, and then what's happening? At pi, the sine takes value 0. But then when I took 2 pi over 3, the output at 2 pi over 3 is the same as here, as the output at pi over 3. So it's going to be basically a total symmetry in the graph. So this is 2 pi over 3. Usually we don't put those in the graph, but only the first time. Again, at 5 pi over the output is a half. So we have a total symmetry on the graph. So the graph is going to actually go down, but totally symmetric with the first piece. So the graph will go like that. And after that, what is doing? Okay. Between pi and 2 pi, we know that the sine will take negative value because when I am between pi and 2 pi, the y coordinate is negative. And that's really what we should reflect here. At pi, we are at 0. Okay. At 3 pi over 2, we are at -1. That's going to be the smallest value the sine is going to take. And then what happened after that? And then the value, as you realize, start repeating themselves, but they are negative. So right here, it's going to be -1/2. So if I put -1/2, that's the value of the sine, the angle is here. And then if I take 4 pi over 3, my angle is here. So the graph is going to be kind of flipping the graph. Total symmetry in the graph of the sine. And then I can repeat the same process, and this gives me like that. And that will be the graph of my sine function. So it starts right here at 0, is go up and down. Now what's going to do after that? After 2 pi? What's going to do after that? So if suppose I take an angle 2 pi plus pi over 6, what's the value of its sine? So suppose I take an angle 2 pi, but I add to it pi over 6. What's going to be the sine of that? Quickly, can anybody tell me? So if I take pi over 6, I add 2 pi of it. 2 pi to it. What's going to be the value of my sine? Do we have to think very hard? I'm listening. 2 pi is 360. If you add pi over 6 of it, what's going to be the sine? It's going to be exactly 1/2. It means the sine is going to start repeating its value. So after 2 pi, if I start adding angles, the value of the sine will repeat. 2 pi plus pi over 6 is the same as the sine of pi over 6. 2 pi plus pi over 3 is the same as the sine of pi over 3. So basically how the graph of sine, so this is the graph from 0 to 2 pi. So if I want to graph the sine in its totality, so first I emphasize the major part, the sine is going basically to start repeating. So it's going to start at 0, it's going to go up at pi over 2, go down at pi. So I'm going to, and then it's going to go down all the way to -1, back up here. This is 2 pi. But after that, the value of the sine will start repeating. So the graph is going to basically go up again, go down, and then back up. And right here, I am at 4 pi. So the graph will start being shifting because the value of the sine are the same every 2 pi. The values are going to repeat themselves. And actually, it's going to start all the way from here. So even if I take -2 pi, the graph will go up the same. The graph is going to go down, and the graph is going to go back up. So that's t. That's the sine of t. So this is the graph of sine over between 0 and 2 pi, and then the graph of sine just for every value of t. So first comment about the graph of sine. Lots of comment. First, sine t is periodic. What does it mean, periodic? It's periodic, it means the output values start repeating themselves. So every 2 pi, so that's a cycle, and the output are going to repeat themselves. So that's another cycle up to here. Exactly because of this reason. If I take the sine at 2 pi plus over 6, it's the same as the sine of pi over 6. Means if I take an angle here, I add 2 pi to it, I definitely have the same value, the same sign. So it's periodic of period 2 pi. One of the most important property of the sine. Second, what's the maximum value of sine? And what's the minimum value? Quickly now, because we have a lot to talk about. I want quick answer. What's the largest value the maximum can take, the sine can take? 1. The minimum value is -1. 3. Whenever you have a periodic function, we ask about the amplitude of the sine and then about the midline. What's the amplitude and what's the midline? Because this is a simple problem. What's the amplitude and what's the midline? Remember, the midline, that's the max is 1 and that's the mean is -1. The midline is the line halfway between the max and the mean. So midline is this one. So the midline is y equal to 0. And the amplitude, as we said, the amplitude is how far is the maximum from the midline. That's the amplitude. So the amplitude is equal to 1. Okay, so 1, the amplitude is, amplitude is 1. So let us look at the graph of sine very carefully, and then I draw the cosine. So the graph of sine, it starts right at 0. Basically, it starts at the midline. It starts right in the middle. It goes up at pi over 2, it reaches its maximum value. It goes down at 3 pi over 2, it reaches its minimum value of -1. So that's the graph of sine that we're going to keep drawing it till it becomes crystal clear in our head. I mean, we recognize it the minute we see it. Okay. Now we're going to do very much similar, hopefully a little bit quicker than that, for the graph of cosine, and see how the graph of cosine looks like. Can I change the page? Okay. So the graph of cosine. Actually, I will do it on, I'll keep it on the same paper. So the graph of cosine will go like that. Graph of cosine. Cosine t. So it means that, what does it mean, the graph of something? It means you take two lines, horizontal and vertical. On the horizontal, you put the value of the angle in radian or in degree, but I'm emphasizing radian more. And here we put the values that the cosine of the angle take. And then we draw. We're going to draw those points. So to draw, I need the values of the cosine. What is the value? So let's go back to the original picture here. If you guys are writing, I'll go back to this picture. Cosine of 0 is 1. That's the x-coordinate of this point right there. Cosine pi over 6 is the x-coordinate. Cosine pi over 3 is the x-coordinate. Cosine pi over 2, the x-coordinate of this point up here, which is 0. 2 pi over 3, and then the values start flipping. That's a minus a half. That's a minus square root of 3 over 2. And the pi will give me a minus 1. So the values are definitely different than the cosine. Let's go into now the cosine. It starts at minus 1 here. At 7 pi over 6 is minus the square root of 3 over 2. It's negative. Minus a half. It's a 0 at 3 pi over 2. And then it's positive. I'm in the fourth quadrant. It's positive. I'm in the fourth quadrant. And this is 1. So these are some of the values of the cosine. Of course, there are a lot of other values, but those are what we call the common angle. The rest, I need the calculator. There is no way out. Let's see how this affects the graph of the cosine. How will the graph of cosine looks like? Okay. At 0, the cosine takes the value 1. So whatever we start, the cosine start at 1. Okay, that's the cosine. Now, always I put pi over 2, pi, and 3 pi over 2, and 2 pi. Those are, they guide us. They guide us totally in the cosine. Now at pi over 2, my cosine takes the value 0. So that's the second point of my cosine. So at 0, it's 1. At pi over 2 is 0. And now what's doing after that? It's square root of 3 over 2, 0.7. And then it takes the value a half at pi over 3. So it takes a value a half. So the value of the cosine actually decreases up to here. The value of cosine gets smaller. And this makes sense because if you go to the unit circle, what's the cosine doing? The cosine is the x-coordinate. So as the angle goes from 0 to pi over 2, the x-coordinate is shrinking. The x-coordinate is getting less and less. And at pi over 2, the x-coordinate is 0. So this is making a lot of sense. Then what's doing after that? When I am in this quadrant, the cosine started taking negative value. At pi, I always emphasize at pi, it takes the minus 1. And they start taking negative value in a kind of a symmetric way. Symmetric way because the values are symmetric. A half minus a half. Square root of 3 over 2 minus the square root of 3. This causes some kind of symmetry, and the graph is going to go down like that. Up to pi. It's negative. So those two values here and here are the same, but opposite to each other. the value here are the same, opposite to each other. Now between pi and 3 pi over 2, we know that the cosine is negative again. And at 3 pi over 2, the cosine is 0. So the graph is going to go up here. And between 0 and 2 pi, it's going to go back up here. That's the graph of the cosine. And then again, it's going to repeat itself. For the same reason, the sine will repeat themselves. So the cosine of t. First is periodic, means the value repeats themselves every 2 pi of period 2 pi. 2 pi, or if you want 360 degrees, means every 360, the angle will repeat themselves. Second, the maximum value is 1, just like the sine. The minimum value is -1. It means the cosine will never exceed the value 1. So if you write cosine t equal to 1.5, it means something is wrong, because that's the maximum value because of the unit circle definition. It's the x coordinate cannot exceed 1, and it cannot be less than -1. The amplitude and the midline. The maximum is 1, the minimum is -1. So the midline is exactly like the sign before it. Exactly. So the midline is y equals 0. And the amplitude is from the midline to the maximum value. So that's the amplitude here or here. So the amplitude is always equal to 1. Okay. And the graph basically is going to keep going like that. The graph will repeat itself like this. Okay. Now, before we start stretching things and moving them, let me compare a little bit the sine and the cosine in here. So you can start building a picture. One of the difference which is going to help you is the sine start at the midline, goes up, down, up, and this is the pi. That's the cosine. Sorry, that's the sine. The cosine start at the top, right there. It goes down at pi over 2. It dips at its lowest value at pi. Then it goes up at pi over 2 and goes like this. So the purple, that's the cosine, and the red, that's the sine. Okay. So cosine start at the midpoint. The cosine start at the maximum value. So this is the sine, and this is my cosine. All right, so these are the two basic graphs that we are going to use basically to find a formula for most of the periodic function that we will encounter. Okay. So today we're going to start this process by taking simple examples. So the first part is we're going to call it vertical stretch. So vertical stretch of the sine and cosine. Now we know the graph of sine and cosine that, as I said, you have to memorize it in a way because it's very important. It comes up all the time with you, pure and simple. So first, suppose I'm giving you the following function. What do I mean by that? Sketch the graph of the following. Y equal 2 sine of t. So we know what the sine of t is. Now we know what the graph of 2 sine t. All right, how are we going to sketch the graph of this function? What does 2 really do to us? Anybody? So we have to draw a point. That's t. And this is 2 sine t. What's going to happen when I multiply the sine by 2? So I'm going to find values. At the same time, I'm going to sketch the graph. So right here, I'm going to start sketching. So before I sketch 2 sine t, I'm going to sketch the graph of the sine function, and then we're going to see what's the relationship between them. So the sine function start right here at 0. Let's go up. It goes down. That's the sine. Back up here. So I'm going to do this in dotted line. So this is y equal to sine of t. My famous pi over 2, my pi, 3 pi over 2, and 2 pi. Now, what is y equals sine 2t? What's the relationship? At 0, I will just take the main value, pi over 2 pi, because that will be enough for, 3 pi over 2 and 2 pi. Okay. What's the value of 2 times sine t when t equal to 0? What does this mean? It means 2, you multiply it by the sine of 0. Now we know what sine of 0 is. The sine of 0 is 0. So that's equal to 0. So at t equal to 0, the value is 0. What happened at pi over 2? That's 2. You multiply whatever the sine take by 2. But at pi over 2, the sine takes the value 1. So if I multiply it by 2, I'm going to get 1. So whatever's happened here, my function will take it at 2. Now, at pi, what's the value of my function at pi? This is 2. Whatever sine take at pi, you multiply it by 2. But sine takes the value 0 at pi. So that's going to be a 0. So these are the values here. Now, what does 2 sine t does? Suppose the sine at pi over 3 takes the value a half. 2 sine t is going to take this value multiplied by 2. So it's basically going to stretch it a little bit. It's going to go up all the way here. So how's the graph of sine 2t is going to look like? It's basically like the graph of y equals sine t, but all the values are going to be stretched by a factor of 2. Because whatever the sine take, 2 sine t will multiply it by 2. If this is a half times 2 is 1. That's 1. That's going to become 2. That's 0. It's not going to change. It's going to stay 0. Now the picture continue. At 3 pi over 2, this is going to take the value minus 1. When you multiply it by 2, it's going to take the value minus 2. It's going to go down all the way to the minus 2. At 2 pi, this takes the value 0. You multiply it by 2, it's going to give me the value 0. So what's the relationship between sine t and sine 2t? What does sine 2? When I multiply sine t by 2, what you're doing is going to stretch the graph of sine t by a factor of 2. Means those, when the sine takes 0 value, they remain 0, and everything else you multiply it by 2. Every 1 you multiply it by 2. So this is going to be a 2. Minus 1 multiplied by 2. It's going to become minus 2. 0 will become a 2. So this will be the graph of y equal 2 times sine t. Okay, so let's take the graph of sine and stretch it by a factor of 2. How will this affect the amplitude? How will this affect everything? So if I take y equal to sine t, what's going to be 2 sine t? That's a new function, totally new. It's obtained by stretching the graph of sine by a factor of 2. So what's going to be the amplitude in this case? Now it's going to be the midline. The midline will not change, y equal to 0. But what is going to be the amplitude? Quickly. The amplitude is going to be from here to here. we're stretching the graph by 2, the amplitude is going to become 2. Okay, so taking the sine function and creating a new function called 2 times the sine of t, its effect is making the amplitude. So we'll get a graph very much like the sine, but the amplitude is going to be equal to 2. So by stretching the graph of sine. Okay, part 2. And now I would like you to kind of participate more. Suppose instead of 2 sine t, I take minus 2 sine t. Means I take the sine multiplied by negative. What's going to be the effect on the graph? Okay, so part 2 is we're going to sketch the graph of y equal minus 2 times the sine of t. Okay, how will this affect the graph? What type of graph we're going to take in this case? Anybody? Okay. I'm going to start with the graph of sine and ask ourselves how multiplying it by minus 2 is really going to affect the whole picture. Actually, I'm going to start with the graph of 2 sine and then how minus 2 will affect the picture. Now, minus 2 sine is like the graph of sine, but stretched by a factor of 2. So this is a 2, and this is minus 2. And this is so this one is 2 sine t. I'm catching this piece. Okay, and this is my pi over 2, my pi, 3 pi over 2, and 2 pi. Now, when I multiply the output by minus, how will this affect the graph? When I multiply it by a minus, how? So this is the 2 sine. How will the output be affected? When I multiply the output by a negative, how will the graph be affected? Anybody has any idea? Yes or no? You usually talk more. You guys are not talking today. It's the opposite. What do we mean by the opposite? How is affected? It reflects. It reflects across what? So at 0, it's 0. That's the minus. And then at pi over 2, the sine 2t takes the value 2. When you multiply it by a minus, it's going to take the value minus 2. At pi, the sine takes the value 0. Multiplying by minus, it stays 0. Now, at 3 pi over 2, the sine takes the value minus 2. If you multiply it, it's going to take the value 2. And this will stay the same. So the graph is we're going to reflect across the x-axis. So that is the minus 2 sine t. It reflects totally across the x-axis. So multiplying it by minus 2, take the graph of 2 sine, which is the stretching, and then reflect it across the x-axis. Okay, so the amplitude is not affected now. So that's the amplitude. It's from here to here. The amplitude, it's still 2. The midline is still the line y equal to 0. The maximum is 2, and the minimum is minus 2. So the minus will take the graph of 2 sine and reflect it. So finally, the last piece before we put all of it together. The last piece is we're going to graph, so I'll do that on another piece of paper. Last piece is I'm going to graph y equal the sine of t, whatever the sine of t is, plus, for example, 3. So I'm going to add 3 to the output. And how will this affect the graph? I mean, what's the graph of this new function? Okay. I start with the graph of sine, and then from there, I build the sine t plot 3. The sine start here. Go up, down, up, down. This is pi, 2 pi. This is pi over 2 and 3 pi over 2. So this is, I'm going to call this one is the sine function. That's the sine. How is sine t plot 3? Exactly what adding 3 is going to, so this is my max is 1 and my mean is -1. Adding 3, everybody tells me you just shift it by 3. Everything is going to be shifted. Everything is going to be shifted. So we're going to shift. So we're going to shift the whole thing by 3. So the 0 is going to be shifted by 3. So 1, 2, 3. So that's going to be the 0. The 1 is going to be shifted by 3. So we're going to shift everything up by 3. So it's going to be a 4, and this is would be the 1. Pi at 0 is going to be shifted by 3. It's going to be right there. The -1 is going to be shifted by 3. So that's a 1. That's a 2. It's going to go right here. So this is going to be a 2 in here, in a way. The 2 pi will be shifted by 3. So the graph you're going to have is up here, go down, up, down. So it's the same graph, but kind of shifted and shifted. All right. Now, shifting the graph will affect what? Only shifting. It's still periodic. The graph is going to continue the same thing. What's going to affect? What's the midline? So the maximum value now, the maximum value is you're going to add 3 to 1. And the minimum value is going to be 2 because that's -1 is going to be 2. And what's going to be the midline in this case? It's halfway between 2 and 4. So the midline is going to be the line y equal to 3. So when you shift the graph, basically, you shift also the midline. So my midline now will not be anymore y equal to 0 because everything is shifted. So the midline itself is shifted to y equal to 3. But in this particular case, the amplitude here is just the same because I did not redo anything to the sine. So the amplitude is 1 in this case, and the midline is y equal to 3. So shifting the graph will affect in this particular scenario, the midline. So the midline now become y equal to 3, and the amplitude will become, in this particular case, equal to 1. So adding, so taking the sine, adding the 3, its effect is moving the midline up and having the midline at y equal to 3. Okay, now I'm going to ask you a question. I'm going to put things together. I'm not going to graph for a minute. Suppose I take the following function. +3. Okay, and let us analyze this function in terms of what's going to be its midline and what's going to be its amplitude. Midline. Okay, let's analyze this function very well. Anybody would like to start? The amplitude is 2. What does this function do? It takes the sine, stretch it by a factor of 2. So it's going to start with the sine, and it's going to stretch it by a factor of 2. So 2 sine t is going to be like that. The amplitude here is going to be 2. So that's the 2 sine t. The +3 is going to take this graph and shift it up by 3. So the shift up is going to shift basically the midline. So the midline is going to be the +3. That's what will shift the midline. And the amplitude is what you multiply the sine by. The amplitude is going to be equal to 2. So this will stretch the sine, stretching the amplitude, and this will shift up, affecting the midline. So this would lead us to, if I did everything with the sine, the cosine is exactly the same thing. So this leads us to the first kind of formula, which tells me the following. In general, suppose we have a function y, and this function has the following form. A number a is a constant times the sine plus a certain constant k, or the function has the form a constant k cosine t plus k. Now the a could be positive or negative, because if a is positive, the graph would be like the sine is negative, we're reflecting the sine. Now, if a function has a following form, then the amplitude is always the absolute value of a. Now, why the absolute value of a? Because when I took y equal minus 2 sine t, my a is actually what's sine multiplied by. The a is minus 2. But the amplitude in this case is actually the absolute value. So the amplitude is equal to the absolute value of minus 2, which is equal to 2. So the amplitude is always a positive number. That's why you put a. And the midline is always the line y equal to k. And this really makes a lot of sense, because what a does is stretch the sine, therefore it's going to stretch the amplitude. What the k would do is shift the sine, and that will affect the midline. So the a change the amplitude because it's stretching the graph, and the k shift the graph, causing the midline to be y equal to k. So I'm going to give you a few functions now. And my question would be, give me the amplitude and give me the midline for each one of them. And please have your camera on. So the question is, find amplitude and midline, only based on the formula. And the period in all those problems is 2 pi. Next section, we will change the period. All right, so I give you the first one, very easy. But this time I'm going to put cosine. 3 cosine t and 3/5, 3 sine t over 5. Okay, so for each one of those, we want the amplitude and the midline. The first one, quickly. This is a -3, yes. Thank you. All right. The first one, what's the amplitude? So that's the graph of, I'm going to sketch that in a minute. So that's the graph of cosine multiplied by 3. So I will go through you and I want answers. And I will pick you as usual, totally in an arbitrary way. David Olson, are you with me? Sorry, Danielle. Danielle Olson, are you with me? Danielle? Okay. Aziz, are you with me? Yes, I am here, Danielle. Okay, then I am here, Danielle. So give me the answer, Danielle. What's the amplitude? The amplitude is 3. What's the midline? 0, because we're adding a 0. So we're not shifting the cosine, we're just stretching it. Y equal to 0. Okay, Danielle, stay with me for the second one. What's the amplitude? And what's the midline? What's the amplitude in the second part? Okay. No, that's not the correct answer. What's wrong with it? The amplitude is always a positive number. So the amplitude is, cosine is multiplied by -3. The amplitude is the absolute value of -3, which is equal to 3. The amplitude is a positive number. It's just the distance from the midline all the way to the maximum value. So it's a positive number. There is no shift here. It means the midline is y equal to 0. Okay, now midline and period. And I will pick another student. Angelina, are you with me? Angelina, yes? Okay, Asia, whatever. Asia, are you with me? Okay, Angelina, what's the amplitude here? And what's the midline? Okay, can you answer us? Chat or just in mute? Okay. Right. The amplitude is, you look at your cosine and you ask yourself, what did I do to the cosine? I multiplied it by 2. It means I stretched the cosine by 2. This is going to be my amplitude. What's going to be the midline? What did I do? I took the function, stretched it, but then I shifted it down a little bit. So, Angelina, what's the midline? Since you started to writing. What I did is I took the graph, taking -1, it means shifting it down by -1. So the midline will be y equal -1. That's going to be my midline. So this by how much we brought the graph one. Okay. Now, y equals 3 sine t over 5. I give you 30 seconds to give me everything. I want the amplitude and I want the midline. Okay, who would like to answer this question? Anybody? You guys are quiet today. Okay, this is a bit harder than the others. The only way you can figure out the amplitude is you ask yourself, what did you multiply the sine by? That's how we figure out the amplitude. So we have to rewrite it. So I can ask myself, what did I multiply the sine by? So how can I rewrite this to be able to figure out what did I multiply the sine by? 3/5. So I multiply it by 3/5. So I have to rewrite it this way. So I figure out what my amplitude is. So this is the same thing at 3/5 times the sine. Means I took the sine and multiplied by 3/5. So the amplitude is going to be 3/5. Now I didn't add anything to it. So my midline is y equal to 0. So that's how we figure out the amplitude and the midline. Now I'm going to pick one of those, one graph, because I worked with the sine before, and I'm going to sketch a graph or two that involve the cosine. So we start seeing the cosine, not only the sine. So let's sketch the graph of the following. So sketch the graph. Off. Okay. First, an easy one. Y equal 3 cosine t. Okay, we start with the easy one, but we have to start seeing the cosine the same way we see the sine. How does the sine differ from the cosine? So I'm going to sketch only the cosine here. So to keep it in front of us, the cosine start up here at 1. That's the cosine. It goes down and then it goes up. So that's the cosine. It starts at its maximum value. That's the cosine of t. So if I want to sketch any of those, I have to remember what is the cosine look like. So 3 cosine t become easy. It's just taking this cosine and basically stretching it by a factor of 3. So the 1 will be shifted to 3. So this is 2 pi. That's a pi over 2, and 3 pi over 2. So whatever happened at 1, we multiply it by 3. At pi over 2, it stays 0. At pi, we're going to go back all the way to -1. At 3 pi over 2, we're back to 0, and then to 2 pi. So that's the 3 cosine t. So it's just a vertical stretch by a factor of 3. You just take it and, you take it and stretch it. So my amplitude here, my amplitude is 3. My amplitude is 3. And if I kept going in the graph, it's going to keep repeating. So I'm going to take this piece. So it's going to keep going like this if I kept going. That's how the graph is going to look like if I keep going. Okay. B, I will only do one more and let us see. Suppose I do something to the 3 cosine. So, and I take b to be, let us say y equal 3 cosine t minus 1. How will this affect the graph? How will this affect the graph? Quickly. We're going to take the 3 cosine and do what to it? Move it down by 1 unit. So we take the 3 cosine, we shift it down by 1 unit. So if I want to graph it, because I'm a little bit slow, I usually like to start with 3 cosine as a guideline, and then I'll shift it by 1 unit. And then really I can see the graph very well. So that's exactly what we are going to do. So one easy way to graph this is start with 3 cosine because it's easy. It's the cosine being stretched, and then shift it down by 1 unit, and then we have our graph. So let's graph this function. So as I said, first I will do 3 cosine, and I will do 3 cosine in the dashed line because that's easy one. The 3 cosine, the cosine start at the max, and that's the mean. And then I always, my strong advice to you is put those particular angle, the most basic ones, into your graph so things will make sense to you. So first I will sketch the 3 cosine as a reference. That's not the graph I want. So I will stretch this as a reference for us. At pi, this goes down all the way down to 3. And then, so that's not the one I want. That's the reference one that I'm going to use all the way to 2 pi. So that's, this one is the 3 cosine t. That's what this graph is. Now I'm shifting everything down by 1 unit. -1 mistakes this and shift it. So this will be shifted down all the way to 2. I'm going to shift it down. What happened at pi over 2 will be shifted down by 1 unit. Now at -3, this is going to be shifted down by 1 unit. This will be shifted down by 1 unit, and this will be shifted down by 1 unit. This is really good, give me a very good eye. So at pi over 2, my new function is going to be shifted down. It's going to be -1 here. And the -3 will be shifted down to -4. And now this is going to be my graph. So we're going to shift everything down, down, down by 1, down, down, down by 1. Again, everything is going to be shifted. Everything is shifted. Everything is shifted. And that's really my graph. Everything is going down by 1. And the red one is the one I am after. Now, by shifting this, of course, the midline of 3 cosine t is going to be totally shifted here. So that's going to be my midline. That's everything is going to be shifted. This will be shifted down by -3. And as you realize, that's halfway between 3 and -4. And this will become my midline. Y equal -1 will become my midline. And my amplitude doesn't change because I'm just shifting. So the amplitude is 3. The amplitude is how far the midline is from the max or the mean. Okay. So this is the graph of 3 cosine t minus 1. So the way you can graph those functions, start with the easy part, like 3 cosine t, because we know how it is the cosine being stretched, and then just shift it down by 1, sorry, and then you have the graph of the new function. Okay, now we're going to start moving backward. What do I mean by moving backward? Now I'm going to give you the graph. I'm going to ask you to find the formula that will fit the graph. So I repeat, right now I'm going to give you a graph. And I'm going to ask you to find the formula. But before I do that, one more time, I'm going to focus on sine versus the cosine. The sine function, when it's shifted, the cosine always start at the max or at the mean. Sometimes if I take the minus cosine. The sine function always started at the midline, because at 0, the function starts. So that's the sine function. Start at 0. So shifting it, when you shift it, it's going to always start at the midline. That's the sine. Always start at the midline. The cosine is like that. So when you shift it, whether you shift it up or down, it's going to always start at the max and then go back. So this is the cosine behavior, and this is the sine behavior. It's very important for the part we're going to start doing right now. So what I'm going to do now, I'm going to sketch graphs. And my question is going to be, find the formula for it. So this is the problem. And we see how we're going to do that. So the question is, find a formula. Find a formula for the given graph. And it is of the following form. A sine t plus k, or of the form A cosine t plus k. So it means that instead of asking you to graph, I'm going to give you the graph. So let's get started with the first easy one, and then I move on. So suppose I give you the following graph. As I said, I have to start with the simple one. Because I put 5 here. This is -5. And this is my 2 pi. And this is pi over 2. And 3 pi over 2. Okay. What's a formula for this graph? So your first question is, what does this graph looks like? Is it a sine or a cosine? Quickly. Since we are starting at the max, that tells me that looks like a cosine. But it looks like a cosine stretched by a factor of 5. So the formula would be, so the amplitude here is 5. So it's 5 times the cosine of t. That's what the kind of questions that we're gonna start doing. So a second graph, which is of course a little bit harder than that, but it's not really very hard. So a second graph, I will do it on another piece of paper. And I want all of you to pitch in. All of you. So this is my graph. I graph it in front of you, so in case you're taking notes, I'm gonna do that. So I'm gonna, that's a 1. That's a 3 up here. And kind of -1 down here. And this is my graph. That's my graph. Okay. And I want to find the formula. First, some guidelines before you find the formula, and then you guys will find it. My first guideline is all the functions I'm giving you are supposedly periodic. So they kind of repeat themselves, even though I'm showing them for now over one period. But usually the graph has to keep going, so it's periodic. So my first question is, what's the midline? I want you to find the midline. Then I want you to find the amplitude. And once we do that, we can answer all your questions. I know a lot of you has figured it out already. First, let us remember how to find the midline and the amplitude. To find the midline and the amplitude, I need the maximum value and the minimum value. Let us remember those a little bit. Okay, the maximum value here is 3. That's the maximum value according to my picture. The minimum value is -1. Okay, so what is the amplitude? The amplitude basically is you take the difference between the max and the mean, you divide it by 2. Okay, or basically you look at the difference, look at the picture. From here to here, you have 3 plus 1, 4, divided by 2 is a 2, or you apply the formula. So which is equal to 3 minus -1 over 2, which is 2. That's my amplitude. Now, what is my midline? My midline is the line halfway between the amplitude, halfway between the max and the mean. So the midline, usually there are formulas for it, or you can use your common sense. It's basically the max plus the mean divided by 2. That's the formula. It means 3 minus 1 over 2 is the line y equal, sorry, my answer didn't make sense, of course, because the picture tells me the one halfway is between here. Okay, so the first step, you draw your midline. And then once you do that, so because I have what's going to be the formula, you look at the graph and you ask yourself, is this a graph of sine and or cosine? That should be your first question. Now, if the graph starts at the midline, you're talking about a sine graph. If the graph starts up, you talk about a cosine graph. So this is the graph, look. So the graph looks like a sine graph. Absolutely like a sine graph. So what's going to be the formula for it? And a lot of you have it correctly. So it's going to be, it's basically the sine. That's the amplitude from here to here. That's my amplitude. It's going to be the sine. So that's the A. Times sine of t, that's the 4, plus, we shift it up by 1, plus 1. So that's going to be the formula that will fit this type of graph. Okay, as I said, we're trying to find formula that actually fit our graph. Okay. Example number 2, and this time I would like all of you to do it. Okay. Second graph, again, I'm gonna graph it for you here. -2, that's a 4, and that's a pi over 2, pi, 2 pi, okay? And I want it to be here, and I want it to be here. Okay, so that's my graph. Start at -2. It's gonna go up to here, go down and down. And then it's gonna continue exactly the same. That's the graph. Okay, we need to find a formula that fits the graph. And that's my pi over 2 right there. Okay, I need a formula that fits the graph. And before you give me the formula, I want the following. I want the max. I want the mean. Then I want the amplitude. I want the midline. And then I want you to tell me the graph looks like what after that. And then I want the formula. So graphs looks like, okay, so I want every answer to each one of them. So midline, and we're gonna draw it. And I will pick one of you, so be ready. Here we go. Okay, Asia, are you ready? Because last time you were ready, but I didn't pick you up. Asia. Yes? All right, help me out with every question. What's the maximum value? Fairly easy. Yeah. 4, absolutely. What's the minimum value? -2. What's the amplitude in this scenario? 3, is she right? Basically, it's the distance between max and mean divided by 2. So we have 6 units divided by 2 will give me the amplitude. Or if you want, you can use the formula. I don't really care, but I want you to understand so we can do it. So it's halfway between 4 and -2, which is a 3. So it's just going to be equal 4 minus -2 over 2, which is equal to 3. That's the amplitude. The midline is the line halfway between -2 and 4. So we know that halfway point is 3. So what's the midline? So she's telling us y equal to 1. I think she's right. So if you want to find it, you take the max plus the mean divided by 2. It means 4 minus 2 over 2, which is equal to 1. So this should be the halfway point right there. So this is the 1. It's halfway. So from here to here, so that's going to give me my amplitude. So from here to here, I have 3. And it should be also from here to here, I have 3. And that's halfway in between. Now, the graph looks like what? Is it a cosine? Is it a sine? Is it a minus cosine? Is it a minus sine? Asia, still with you. She's absolutely correct. It's a cosine graph, but it's a minus cosine because the positive cosine start here. And this one is starting down here. So it's not starting at the midpoint. And the midpoint is the sine. The cosine start at the max or the mean. So the graph looks like minus cosine. That's how it looks like. So now let us put all of it together. What's going to be the graph? I stay with you, Asia. What's going to happen? So my amplitude is 3. The graph is the cosine. So basically, I stop. Aisha, would you like to give me your answer? Anybody? Anybody? So I want the graph, I want the equation of the form A equal A cosine T plus K. Okay, that's really how the graph looks like. So let us go through every piece here. My A here is not actually the amplitude. This A could be positive or negative. So in my case, it's minus 3. 3 is the amplitude, and minus 3 because my graph is like the cosine. So it's minus 3, the cosine of t. But then I shift it up. The midline is at 1 plus 1. And that will give me the graph of the formula that will fit the graph. In other words, if you pick up your calculator, actually pick it up and sketch the graph of this function, which I will do next time, you should get exactly what you see. So if you want to check, are we getting everything makes sense? You pick up your calculator and graph this function. And you should get exactly what's given to you. And we will do that, we'll verify this next time. Right. So that's it for today. Please do the homework. What we will develop in section 7.5 is actually the same approach, but we're going to change period. It means so far my period is 2 pi. But in a lot of problems, if you guys remember when we did those Ferris wheel problem, the period was 2 and 3. So the question is, what is the function that we're going to use to be able to make the period 2 or 3? So today we're sticking to the scenario where the period is 2 pi. All right. So that's it for today. Please do your homework for next time. All right. Any questions before I let you go? Any questions? Okay, bye and have a good weekend. And please next time talk more. Bye-bye, guys.